Hello everyone, my name is Sowjanya. I'm working as an assistant professor in data science department in Vienna VJIT. So today we will go with a topic called as in recursions in C. So before going to recursions in C, so the recursions topic is came from the topic called as in functions. What is a function? A function is a subprogram. Use it to simplify our task, right? So can we call a function within a function? Yes, we can call a function within a function. So that terminology in programming is called as a recursion. So that the definition is nothing but a function calling itself is called as an recursion. So coming to the definition, so recursion is a process in which a function calls itself directly or indirectly. So we will take a real-time example like, for example, if you are in a long queue, you don't know how many persons are there in front of you and you don't know how many persons are there behind you. So it will take a time for you to count the people who are in front of you or behind you. So for that purpose, what you can do means you can ask the person behind you, what is your count? So similarly, the person can ask the next person, what is his count? So standing itself there only, you are doing your work in an simplified format. So recursions is in the same way. That means it is making our task by calling itself again and again. It can be directly or indirectly. So when you are considering a recursion functions, you have to observe, you have to take care of these two conditions. The first one is a base case and the second case is a recursive case. What is meant by a base case? A base case tells us when to stop the recursion conditions. So, and the recursive case will tell us what are the inputs and how many times it has to call itself. So let us take a syntax for this. So while writing a recursions, first you have to mention the return type and the function name, whatever the function you are taking, and you have to give the parameters on it. And in the base condition must be in the if case, if the base condition, and you have to give the return value and else return and the function name. So here the function name. So you are calling, we will consider a simple example like, for example, you are having an a function. In that, you are calling again a function, right? So clearly look at this. So you are calling a function. In this, you are again calling a function a. But whenever you are going to this function, this causes an infinity. Why? Because in this function, you are not giving any base case or any recursive case. So you have to be clear while giving a recursions whether you are mentioning the base case or recursive case or not. So for that, you have to write a function. In that, if you have to mention the base case, what the base case will tell, when to stop the recursion conditions, and after fulfilling that, it will go to the, if the base condition is false, it will go to the else condition. In else conditions, and you are again here calling a function, and this function call again itself. So this is about the recursion. We will see with an example. So recursions means using a factorial is a very regular example. We will just look at into it. So here we are giving the header files. What is our header file means? Hash include stdio.h. What is a factorial? For example, consider the 5 factorial. So how we will write the 5 factorial? 5 into 4 into 3 into 2 into 1. That means carefully observe that we are considering the 5. 5 means again we are going back to minus 1. That means 5 minus 1. We are having 4. Again 4 minus 1. 3. Again 3 minus 1. 2. Again 2 minus 1. 1. Now we will try to solve the exam in programming. So first we have given the header file, and after that we are mentioning a data type called as an int. This is our function called as a function name is a factorial, and these are my input parameters. What are my input parameters? N is my input parameter, and we are going to the inside the function as if. Here is my base condition. What is my base condition? N if n double equals to 0. If n double equals to 0 means it will return 1. If n is not double equals to 0 means it will go to the else statement. In that it will return again the function n into factorial. What is our factorial? N minus 1. That means here we are calling our function again as an n minus 1. Now let us trace it out. So the programming starts from the main function, right? So here the compiler starts from here, int main. So here int my number is my variable. I have assigned it as a 5. Printf factorial of num of factorial of num. Now I am calling a function called as an factorial num. So now the control goes to the function factorial, right? So here num is my actual parameters, n is my formal parameter. Right? So here n is a 5 here. N is 5 here. Let's trace it out. So int factorial of int of n, that means int of 5. Int of 5. So now we are going to the inside function. If n double equals to 0. What is our n here? 5. 5 double equals to 0. Is 5 double equals to 0? No. The condition is false. That means it will return to the else statement. It will return to the else statement. In else, what we are returning? N into factorial of n minus 1. That means what is our n value here? 5. 5 into factorial of n minus 1. What is n minus 1? N is 5. 5 minus 1, 4. Factorial of 4. That means again we are calling a function called as a factorial. So the control goes to the factorial function again. And now here what is our n value? 4. Our n value here becomes as a 4. So if 4 double equals to 0, is 4 double equals to 0? No, false. 4 is not equals to 0. Then it will go to the else statement. Again it will check that n. What is our n value here? 4 into factorial of n minus 1. That means 4 minus 1, that is 3. Factorial of 3. So again this function is again calling itself. Again the control goes to the function and again it will check the base case. What is the base case again? N double equals to 0. So what is our n value here? 3. 3 is equals to 0? No. Then it will return to the base case 3 into factorial of n minus 1. That means 3 minus 1 comes under the factorial of 2. Again it goes to the main function, check the base condition. The base condition is not equals to 0. That means it will go to the else statement as 2, n value is 2 now. 2 into factorial of 2 minus 1 is 1. Again the function is calling itself. It goes to the main function and check the base condition. So n value is here 1. 1 is equal to 0? No. Else it will return as 1 into factorial of n minus 1. What is n minus 1 means? 1 minus 1, 0. So now it again go to the function factorial. So factorial now n value is 0. Carefully observe now. Now our n value is 0. So here it will check the condition. So what is our condition here? N double equals to 0. What is our n value here? 0. So 0 is equals to 0? Yes, 0 is equals to 0. Then it will return 1. What is the answer for factorial of 1? It is 1. Factorial of 0? 1. So the recursions will be stored in a format of a stack. In a memory, it will store in a format of a stack. What is our first value we have pushed down? 5 into fact of 4. Fact of 5 into fact of 4. The next value we pushed is 4. 4 into fact of 3. The next value is 3 into fact of 2. Factorial of 2. Again 2 into factorial of 1 and 1 into factorial of 0. Clear? So at factorial of 0, if we check with the base condition, here we got n value as a 0, the base condition. This is the step where we have to be careful while using a recursions. Clear? Here we are mentioning that if we are going to the 0 means you have to return a value called as a 1. So the factorial of 0 is now 1. So do the calculations. It will stack is in the form. So 1 into 1, answer is 1. The fact of 1 is 1. 1 into 2. 2 ones are 2. So it will return here 2. So fact of 2 means answer is 2. 2 3s 6. Right? Fact of 3 is 6. 6 4s are 24. 24 is returned to 5. Now 5. Factorial of 5 into 5. 120. Done. So this is how we are doing a recursions in factorial. So now consider again another example called as a Fibonacci series. So Fibonacci series means it is having a golden ratio. So in our university, which is having a beautiful means, it is near to the golden ratio. So how we will give the Fibonacci series means adding the sequence of two numbers 0, 1, 1. These are my input numbers. Okay. So if we add 0 plus 1, what the answer will be? 1. 1 plus 1, answer will be 2. 2 plus 1, answer will be 3. 3 plus 2, answer will be 5. Right? So this is a sequence of adding a sequence of two numbers beforehand is called as a Fibonacci series. So now we will do a recursions in Fibonacci series, right? So we'll start with a header file. Int is my return type here, feb is my function name, and n is my parameters, right? So this is my function, and the compiler starts from the main function. So int main. Now I am giving a looping conditions for int I equal to 0, I less than 6, I plus plus. So here my I value is 0. So printf %ld feb of I. Feb of I is my function here. So the control goes to the function. The control goes to the function called as a feb of int n. So what is my n here? This is the formal parameter. What is my actual parameter? I. What is the I value now? 6. So I value will be taken. That means n value will be considered as a n value will be considered as a 0. Here into the function. Now we are going into the function. So if n is less than or equal to 1. So this is my base condition. Now I am checking my base condition. Remember one thing, while writing a recursions, you have to consider the two conditions. One is a base case and the other one is a recursive case. What the base case will do? It will tells us when to stop the flow of our function. What is a recursive case? How many times we have to repeat. So here the base case will be given in an if condition. So what is my base case? It should not be less than or equal to 1 and should not be less than or equal to 1. If it is less than or equal to 1, it will has to return the value called as an n. It has to return a value called as an n. What is our n? So here what is my n value here? 0. So is this less than or equal to 1? Yes, it is less than or equal to 1. That means it will return a value called as n value. What is my n value? 0. And again the control comes to the for loop. We are in a looping condition. That means until the condition fails, we will be in the loop only. Now the L value will be incremented to 1. So now my n value is 1 here. I value is 1 here. So again feb of I. What is my I value? 1. It will go into the loop. Feb of 1. So is less than or equal to 1? Is n less than or equal to 1? Yes. Why? Because my n value is 1. 1 is equals to 1. Then it will return the value called as an n. What is my n value here? 1. It will return a value 1. Again we will come to the for loop. Now it will again increment to plus 1. Now my I value is 2. So it will return to the function again feb of 2. So it will check the base condition. What is my base condition is here? 2 is less than or equals to 1. Is 2 is less than or equals to 1? No, 2 is not less than or equal to 1. Then it will go to the else statement. Else, what is my recursive case here? Return fab of n minus 1 plus fab of n minus 2. So what is my n value here? 2. Fab of n minus 1 plus fab of n minus 2. What is my fab n value here? 2. So fab of 2 minus 1 is 1. 2 minus 1 is 1. Fab of 1 plus fab of 0. Fab of 1 plus fab of 0. Then again it is calling itself. So this all will be stored in a format of a stack value. So what we are storing here? Fab of 1 plus fab of 0. So again it will go here only. Now, so what is the fab of 1 means? It is 1. Fab of 0 means 0. So 0 plus 1, 1. It will print 1. Again, we have to come to the looping statement. Now our n value will be increment to 1. Our I value will be increment to 1. So now the I value will be 3. So consider fab of 3. Then again it will go to the function called as a fab. So now it will again check the base case. Is 3 less than or equals to 1? No, 3 is not less than or equals to 1. It will return to the base case. Again, fab of 3 minus 1 is 2 plus fab of 3 minus 2 is 1. 3 minus 2 is 1. So what is the fab of 2? 1. And what is the fab of 1? 1. 1 plus 1? 1. It will return the condition as a 1. 1 plus 1, sorry, 2. 1 plus 1, 2. It will return the condition, it will return the print the statement as in 2. Again, we will go to the for loop. Now the I value will be incremented to 1 and my I value is here 4. So again, it will go to the function, check the base case, and if the base case is not satisfied means it will return to the else case, recursive case. Here my recursive case is my n value will be 4 here. Now fab of 4 minus 1 is 3 plus fab of 4 minus 2 is 2 here. That means fab of 3 is this one, fab of 2 is this one. That means 2 plus 1, 3. Done. Again it will print a 3 statement. Now the I value will be incremented to 1 and my I value will be 5. So now it again go to the condition, checks for the base case. If the base case is not satisfied, it will go to the else case and it will check the recursive case. What is my n value here? 5. That means fab of 5 minus 1, 4 plus fab of 5 minus 2, 3. That means 2 plus 3. What is the value? 5. 5 will be printed here. Again, my I value will be incremented to 1, 6. It will check. So I equal to 6. Is 6 less than 6? No, 6 is not less than 6. It is equal to 6. That means my loop stops here. And my Fibonacci series are 0, 1, 1, 2, 3, 5. So what is the base case? Carefully observe that. What is the base case I am giving here? If it is less than or equals to 1, it has to return 0. It has to return that n value. Or else what is my recursive case means n minus 1 plus n minus 2 is my recursive case. So the recursions in will be stored in a memory called as a stack memory. Now we will see what are the advantages and disadvantages in recursions. So advantages comes means here it is easy to understand a problems like an factorial, recursive, tree traversing. Why? Because we don't know what is the depth of a tree, right? In that cases, if we are using a recursions means it is very easy to solve a problem, and these recursions are very elegant and clean code. So no need of writing a functions again and again. So recursions makes it easy. So there are some disadvantages while using a recursions. The first disadvantage is it uses a high memory. So if you are using a stacks means the memory usage will be very high. You have to store everything. Then slower than the iterations. So if you are using a trees, graphs, recursions are best. If you are using a solving a simple examples, then it is better to go to the iterations. Simple problems will be solved by using an iterations than recursions. So there is another disadvantage called as a stack overflow. So if the risk of stack overflow, the recursions will be too deep. So while considering a recursions, you have to keep these things in your mind. So if you are having a low memory usage, better to go with the recursions. If it is a complex problem, better to go with the recursions. If you are then what is the differences between a recursions and iterations? So recursions means it uses a functions calls and it requires a base case and it uses a stack memory, slower but simple. These are about a recursion. So what is meant by iterations? It uses a loops. In recursions, we are using two conditions, right? What is the first one is base case and the next one is recursive case. But in iterations, we will use the looping statements and we will use a conditions to terminate also. Here the memory is constant and it is faster. So my suggestion is if you are solving a complex problem using a trees graphs, it is better to go with the recursions. If you are solving a simpler problems, then it is better to go with the recursions. So the overall summary of the recursions is what is meant by recursion means a function calling itself maybe directly or indirectly. So while writing a recursions, you have to keep in mind whether you are mentioning a base case or not. You have to definitely mention a base case. What the base case will tell when to stop the recursive case. What is the recursive case? How many times you have to call will be standing by the recursive case. The examples for the recursions are factorial and Fibonacci and merge sort. But you have to be very careful while writing a recursions to avoid the infinite recursion case. You have to avoid the infinite recursion case. When we will enter to the infinite recursion case? If you are not mentioning the base case. So be clear while writing a base case. So the base case should be very clear that tells us when to stop the recursions. So this is all about the recursions. Thank you.